for a second. I really want you to pay attention to this picture. Really study it for a second. I'm looking for some comparing and contrasting here. Start with Schmuck. Schmuck, what do you see that's similar, that's different? What do you see?
Well, it looks like they're pretty spread out.
Okay, spread out.
Looks like there's warm ones, like right next to warm ones, and then there's cold ones right next to cold ones.
Okay. Do you notice any other patterns about warm and cold?
Warm's going north and cold's going south.
Well, it depends. Because in this case, warm's going north, or cold's going north and warm's going south. In this case, the cold's going south. So, not good though. Go ahead, Drew.
It's not really with the.
Loud, Drew, what?
It's
Mold.
not really with the heat, but it seems like they all kind of follow the continents.
Good. So the current shapes are kind of based on what the land masses are. What else? West.
Like the cold water is going towards the equator and the warm water is going away from the equator.
Excellent. So direction is not a great way. You're just saying away and towards. Good. Excellent. What else, Ash? What do you see? There's what? Okay. Let me ask you a new question then. Do you see any differences between the northern hemisphere and the southern hemisphere? Besides going opposite directions, obviously. You know, one goes north and one goes south. But what else do you see? There's a lot of blue at the bottom. Hey, Wes. Hey, Lane. What's up, Lane?
In the north, warm water goes into the cold, and in the south, the cold goes into the warm.
Okay. That was kind of what Wes said. Comes down into the equator in a way. Sarah, what do you think?
They're, besides the ones at the bottom, they're pretty much all moving in like a circle.
There you go. You see this word gyre right here? G-Y-R-E. Gyres are circles of currents. And if you notice, all these currents basically are in circles. Yeah, there are all these things called gyres. Do you notice anything about those gyres? Look carefully. Look at the northern hemisphere compared to the southern hemisphere. Caroline.
There's like no whatever gyres or whatever. There's like no gyres in the south.
There's not as many. Why do you think, Caroline?
I don't know.
What's different about the south than the north?
Well, there's just like none. I mean.
There's a couple. There's actually one right here. You can see the South Atlantic Gyre, the Indian Gyre, there's a South Pacific Gyre. The East Australian Current is actually part of that. So there are three main gyres down here, and there are more up here. You're correct. Why do you think, though? Take a shot, yeah. Try to throw.
Maybe, I don't know.
Just throw it out there. What do you think? Look at the north and look at the south. Somebody said earlier, was it Tanner? Or maybe it was Drew, something about the land masses, right?
Yeah.
Kind of shaped like the land masses?
There's no land in the south compared to the.
Good, Caroline. There is less land in the south than in the north, so there are fewer gyres. Very good. Nate, do you notice anything different about the gyres in the northern hemisphere compared to the southern hemisphere?
Well, in the northern hemisphere, all of them are just kind of moving in. They're all. It looks like they're all moving in different directions, but down in the southern hemisphere, it's like they're moving all in one direction.
What do you mean one direction?
Like
No,
down towards,
Sarah's crazy. Relax.
down towards Antarctica, they're all moving east.
Okay, these aren't actually, you're talking about down here?
Yeah.
Okay, these aren't really gyres. These are just because the wind, there's no land down there, so the water just flows. Good guess, though. What else? Sarah, do you notice anything?
In the northern hemisphere, there's all going in the circular motion, but towards Antarctica, they're going in like straight line.
That's what Nate just kind of said. Go ahead, Sam.
They're smaller in the north and bigger in the south
They are. Why again, Sam?
because there's more land mass in the north.
Good. There's one other thing that you guys haven't noticed yet. Tanner?
There's more blue down south.
Yeah. Again, same thing. The southern hemisphere is, the water's colder down there because there's less land. What do you think, Lance?
The gyres are between two land masses,
Yeah, that's true of both, though.
so.
Jacob?
Gyres in the north are going clockwise and the gyres in the south are going counterclockwise.
Jacob. Why? There's a few that aren't. We'll talk about what I say.
Is it maybe about like gravity?
Not gravity, but that's an excellent answer. That's one team after class, Jacob. Clockwise in the north, counterclockwise in the south. Now here's the question, why?
Convection.
Nope, good try.
Darn.
What do you think? You gonna say the same thing? Notice, these don't really cross the equator, do they? This one's running right along it, but otherwise, they're all going away from the equator, aren't they? Does everybody see that? Remember we talked about weather last year?
Yeah.
What happened to hurricanes when they got close to the equator? They died. They stopped. Why? Nate?
Is it because nothing can't cross the equator, like you said? If, like, the hurricanes came onto the equator, they basically all just went in a straight line.
Not a straight line, and there's not a force field, Sam. Go ahead.
Because if it had a cross, it'd have to rotate the other way.
Exactly. So basically, it would have to stop itself first, right?
Yeah.
Why?
Because the winds are different.
Wind blow out of the west and blow out of the west down here too, usually. Sarah?
Nothing to do with magnetic field.
It's a great guess. I've got that a lot today. No, magnetic field doesn't have anything to do with it.
Have you learned about it?
Let's say, we'll move through quickly.
What about the salinity?
The what? Salinity? Good guess too. These are surface currents, so they're caused by wind, right?
Oh.
Put it on the middle. Grab the lights, Lane. Sorry, Lane.
Thanks for asking.
Need the lights?
Yeah.
Nice, Bryce. Okay. Doesn't make any sense. I want you to think about something. Let's say Lane's a terrorist. Sorry, Lane. Let's say Lane is going to shoot a cannon. He's not a very sophisticated terrorist. He's going to shoot a cannon, a really high-powered cannon, all the way from Columbia, all the way to New York City, straight north. He can't. It's a cannon, so he just has to shoot it, and that's where it goes, right? So he shoots his cannon, shoots it up in the air. It's up in the air for a little while. He's going for New York City. Unfortunately, it hits over here in Iowa.
Well, thanks.
Gosh darn it, Lane.
Sorry.
Why would it hit in Iowa, Lane, when you shot it straight?
The wind.
I get it.
No wind.
Yeah.
On the wind.
Not, well, wind would, yeah, but no. Good try. If that was the case, wind would blow it this way. You know.
Maybe it was like a...
Schmelk, what do you think?
All the way around.
Why would that make a difference, Schmelk?
Because if the Earth is rotating and shooting straight, then the Earth would be moving, but it would still be on straight.
Schmelk can see me after class. So what actually happens is Lane shoots his cannonball up in the air. As it's up in the air, the Earth actually turns, and it ends up here. So it appears like it's doing what? Curving. Where in the southern hemisphere, Lane, still a terrorist, he's going to shoot Antarctica. Those people in Antarctica have been bothering him a lot. Those 4 people down there. So he shoots his cannonball south, straight south. But unfortunately, as it's in the air, what happens? It's turning. Now notice, shoots it south. As the Earth turns this counterclockwise direction, it appears like it's curving which way? To the right. Does everybody see that?
Yeah.
Whereas in the northern hemisphere, he shoots it north, and it's still curving. It's still turning this way, right? Where does it look like it goes? Left. So therefore, we get opposite rotations because of this thing called the Coriolis effect, which we'll talk more about tomorrow. But that's why we have these gyres. Do you remember how air does this too? Remember how air pressure, high pressure rotates one way and low pressure rotates the other way? It's the same deal. It's all based on the rotation of the Earth.